You ever see a system that becomes a victim of its own success? You know, it starts out all simple and elegant, but then new features get bolted on one after the other, and suddenly it's just this tangled mess. Well, today we're going to explore a really powerful pattern that can stop that from happening, and we're going to do it through the story of a developer named Timothy and his very, very wise mentor.
So imagine this. You propose a solution you think is perfectly logical, and your senior engineer just looks at you and says this. That one sentence from his mentor, Margaret, it just stopped Timothy right in his tracks. So what was he doing that was so wrong, and what does it even mean to recouple in architecture?
Okay, so to really get what Margaret was so worried about, we have to meet Timothy. His checkout service, it was a thing of beauty, a model of stability. He used a message queue to insulate it from any downstream problems, and it worked perfectly. But you know how it goes. Success always brings new requests.
And yep, the product team always wants more. So now, when a customer clicks that Buy button, the system has to do 3 totally new things. First, update the inventory. Second, ping the fulfillment service so it can print a shipping label. And third, trigger the notification service to send out a receipt. That is, a lot to ask from one single event.
So, how would you solve this? Timothy's first instinct was, well, the most direct one. It seemed simple, it seemed clean and logical. But this, my friends, is exactly where the trap is set. Let's take a look at his initial plan.
So here's Timothy's plan. He'll just modify the checkout service so it sends 3 separate messages, one for each queue, one for inventory, one for fulfillment, and one for the email service. I mean, it seems logical, right? It's all asynchronous, so the checkout process isn't blocked. But this is what made Margaret raise the alarm.
And this, right here, this is the heart of the problem. Margaret pointed out that the checkout service now has to know about every single downstream service. Just think about that for a second. What happens next month when the analytics team decides they want a feed of all the orders? You guessed it. Timothy's got to go back, change the checkout code, and then redeploy the entire service just for that one little change. The whole system becomes incredibly brittle.
So Margaret proposed a pretty fundamental shift in thinking. Instead of having the checkout service point directly to every single team that's interested, it should just shout into the void. Just announce that an event happened, and not care who's listening.
This right here, this is the big idea. The checkout service's only job is to confirm that an order was placed and then publish that one single event. That's it. What happens after that, not its problem. And that is the absolute beauty of a decoupled system.
The pattern Margaret is talking about is called publish/subscribe, or you'll hear it called pub/sub. The best way to think about it is like a radio station. The publisher, that's our checkout service, is the DJ broadcasting a song. It has no idea who's listening. And the subscribers? They're all the listeners who decided to tune into that station because they want to hear that song. The DJ never even knows they exist.
And in the AWS world, the perfect tool for this job is Amazon's Simple Notification Service, or SNS. With SNS, our publisher doesn't send messages to all these individual queues. Nope. It sends one single message to a central hub called a topic. You can just think of it like a public bulletin board.
Okay, so we've got a publisher and a topic. Now, how do we get the messages from that central topic to all the different services that need them? Well, this is where we get to build the super elegant and scalable Fanout pattern.
Just look at how simple this is now. The checkout service does one thing and one thing only. It publishes a single message to the order-placed topic, and then its job is totally done. SNS takes over from there, fanning out that message to every single subscribed service automatically.
And that is the Fanout pattern. It's just so elegant. One message comes in, and it's fanned out to a whole bunch of destinations all at the same time. This doesn't just allow for massive parallel processing. Crucially, it keeps all of our services completely independent of each other.
Let's just put them side by side. On the left, you've got Timothy's original plan. The publisher is literally chained to its subscribers. It's rigid, it's brittle. Then on the right, with the Fanout pattern, the publisher is just firing off a message, completely ignorant of who's going to catch it. And that's what makes the system so flexible and so scalable. Adding a new service is now a simple configuration change, not a whole redeployment.
But Timothy, being a sharp developer, he raised another great point. What if not every service actually needs every single message? This is a super common real-world problem, and this pattern solves it beautifully. He asked, hey, what about digital gift cards? The fulfillment service doesn't need to print a shipping label for a digital product.
So are we going to have to add code to the fulfillment service to check the item type and just ignore the messages it doesn't care about? And the answer is a big, fat no, thanks to this incredibly slick feature of SNS called filter policies. Just look at this simple little JSON rule. The subscription for the fulfillment queue is basically telling SNS, hey, listen up, only send me messages if the item type is physical. It is literally that easy. And the result here is so powerful. The message routing logic is handled by the AWS infrastructure itself, not by our application code. SNS looks at the message, sees it's a digital order, and just doesn't deliver it to the fulfillment queue. That service only gets the work that's relevant to it, making the whole system way more efficient.
Okay, this all sounds amazing, I know. But before you run off and start implementing this everywhere, let's cover a few real-world limits and guarantees that you absolutely need to know about.
First up, size. And yeah, it matters. There's a little catch. SNS has a strict payload limit of 256 kilobytes. That's really not a lot. So what do you do if your order event is massive?
Don't you worry, there's a really clever solution for this, and it's called the claim check pattern. All you do is store the big payload somewhere else, like in an Amazon S3 bucket. Then you just publish a tiny little message to SNS that has a reference, a claim check, to that S3 object. The subscriber gets the claim check and then uses it to go fetch the full payload itself. Problem solved.
And finally, a super crucial point about delivery guarantees. Standard SNS promises at least once delivery. Now what that means is, in very rare cases, your service might get the same message twice. This is why your services have to be idempotent, which is just a fancy way of saying they can safely process the same message over and over again without causing any problems. And if the order of your messages is absolutely critical, you'll want to look into SNS FIFO topics.
And this brings us right back to the end of the story. Timothy asked what would happen when that analytics team finally came knocking for their feed of orders. Market's response was the ultimate proof that their new architecture worked. You don't touch the checkout code. You just add a new subscriber. The system now scales itself.
So the question I want to leave you with is this. As your own systems evolve, are you just adding more connections, making everything more tangled and more rigid? Or are you adding new, independent capabilities that make the whole system more powerful and flexible? Because that difference, well, that's everything.